Good day everyone. In this video, we are going to talk about de Broglie's wavelength. This is Leo Sinelio from Basic Science 3A. De Broglie's wavelength is the wavelength that is associated with an object in relation to its momentum and mass. So particle de Broglie wavelength is usually inversely proportional to its force. Given its the wave and particle duality, so that is the formula of de Broglie's wavelength. We have here the lambda or the wavelength is equal to h, or that is the Planck's constant, divided by the p, or the momentum is, or it could be the momentum is equal to mass multiplied by velocity. And we have our second equation. We have here the frequency of matter wave is the force. The force is equal to the energy divided by the Planck's constant. So let's going to answer the problem number 1. So we have here, it states that an electron with a speed of 1.5 times 10 raised to the power of positive 6 meter per second. So what is the de Broglie wavelength in nanometer? So first, identify the given. We have here the velocity of 1.5 times 10 raised to the power of positive 6 meter per second. And the mass of electron, that is 9.11 times 10 raised to the power of negative 31 kilogram. And we are going to find its wavelength, or that is the lambda in nanometer. Alright, so this is the equation that we are going to use. That is wavelength is equal to the Planck's constant h divided by the momentum. So equation, so plug in all the given values. We have here h, that is Planck's constant, that is equal to 6.626 times 10 raised to the power of negative 34 kilogram per meter squared over second. So we have here the mass of an electron, that is 9.11 times 10 raised to the power of negative 31 kilogram, and the velocity, that is 1.5 times 10 raised to the power of positive 6 meter per second. So we have here cancelled out the same units, kilogram and kilogram. We have here meter and meter, so we have here seconds and seconds, so we have meters remained. So just copy 6.626 times 10 raised to the power of negative 34 meter, because here meter here is squared, so cancelled out the other meter, so we have here meter remains. And 9.11 times 10 raised to the power of negative 31 multiplied by 1.5 times 10 raised to the power of positive 6, that is equal to 1.37 times 10 raised to the power of negative 24. So 6.626 times 10 raised to the power of negative 34 meters divided by 1.37 times 10 raised to the power of negative 24, that is equal to 4.84 times 10 raised to the power of negative 10. And since our problem is to find the wavelength in nanometer, so we converted from meters to nanometer, that is equal to 0.484 nanometer. So this is now our wavelength. So let's move on to another problem, that is problem number 2. So find the speed of an accelerating electron given the de Broglie wavelength of 50 nanometer. So given of the wavelength of 50 nanometer, that is 5.5 times 10 raised to the power of negative 8 meter, and mass of the electron, that is 9.11 times 10 raised to the power of negative 31 kilogram. And we're going to find our V, or that is the speed of the accelerating electron. So again, let's use our equation. So equation of the lambda, or the wavelength, is equal to the h, or the Planck's constant, divided by the momentum. So in order to find our here, so let's multiply both side by velocity over 1, the velocity over 1, so that is now cancelled out, the velocity and velocity. So we have here, alright, here, so v multiplied by wavelength or lambda, that is v lambda is equal to h divided by m, that is the mass of the electron. And in order to cancel out, cancel out the v, in order to find the lambda, so that is we're going to divide both side by lambda. I mean, in order to find our v, so let's multiply both side by 1 over lambda. So 1 over lambda here. So we are going to cancel lambda and lambda, so v remains. So we have our final formula or final equation of v is equal to h, the Planck's constant, divided by mass multiplied by the wavelength or the lambda. So now let's substitute all the given values. So we have here h, that is 6.626 times 10 raised to the power of negative 34 kilogram meter squared per second. So that is the Planck's constant. So the mass of the electron, 9.11 times 10 raised to the power of negative 31. And our lambda here, so we have here the wavelength of 5.10 raised to the power of negative 8 meters. So cancelled out the same units, that is kilogram and kilogram, meters and meters. So we have here the answer of 4.56 times 10 raised to the power of negative 38. Alright, so meter per second remains, that is the unit of our velocity. So we have here 6.626 times 10 raised to the power of negative 34 meter per second divided by 4.56 times 10 raised to the power of negative 38. So that is equal to 1.45 times 10 raised to the power of positive 4 meter per second. So that is now our accelerating, the speed of accelerating electron. So that is equal to 1.45 times 10 raised to the power of positive 4 meter per second. So that's it. Thank you for watching, everyone.